DevOps training is rated as the most valued IT certification. Secondly, the DevOps market is expected to reach $236 billion by 2020 at CAGR of, and this is claimed by the Forrester Market Research Agency of US. And the third reason that you should opt for DevOps course is that 80% of global Fortune organizations are expected to adopt DevOps by the end of 2019, and we are all into the way. These are the market trends for DevOps terms from various search engines like Google, Yahoo, and DuckDuckGo. So you can see that the data starts from 2013, and it had been rising in an exponential manner until 2017, and we are in 2019 now, which is well beyond the inclination. So what the future holds for a DevOps engineer? So if you see, DevOps is not only a part of IT industry, it is also a part of telecom, retail, and other industries as well. So this attribute starts from the basic year of 2014. Since then, it has been raising exponentially, and that's how the demand for this job profile is in the job market. So these are some industries who are looking for a DevOps professional. Even if you are a DevOps engineer and you have skills of every DevOps engineer today under your belt, it is not just a IT company which would be hiring you. Tomorrow, business development companies would require DevOps as well, consulting companies, entrepreneurship companies as well. And you can be an entrepreneur as well, along with these skill set under your belt. So these are some median annual salary figures of a DevOps engineer in USA, and it's comparable to Indian salaries as well and around the world. So with less than an year of experience in DevOps, you can earn around $91,000 in a year, and it goes up to 135 as your experience grows. These are some major companies around the world which are looking for a DevOps engineer today, which includes Microsoft Azure, Yahoo, Apple, Microsoft, VMware, EMC Square, AWS. These are some major ones, and the rest you can see on the screen as well. Um, Prakash, I got your message that the content and the syllabus will be shared just now. So this is the skill set which we'll be covering in the course, and these are all the stages of the DevOps course which would be covered. So this is the DevOps pipeline and the course content which we'll be covering. So as a part of DevOps, these are five main stages of a DevOps cycle. So in code and commit, we'll be working on Git as a part of this course and Nexus. And build and config, we'll be working on setting up Docker and containerization. And later we'll be moving to Puppet, which would be a configuration management system. It is just exactly same as AWS CloudWorks, but we won't be looking into that module, but we'll be working on Puppet. And the same thing is done by other applications just like Ansible as well, which is also a configuration management tool. So we'll be focusing on Docker, Puppet, and AWS over here. In scan and test, we'll be working on Sonar, which is a code quality test. And there are many testing tools like JUnit and Cucumber. Then we'll go to the release stage of DevOps, in which we'll be using Jenkins again. And apart from that, you deploy as well, and Excel release. Finally, we'll use the Azure services, AWS services, and Docker to deploy. And there is the hottest trend in the market, which is OpenShift. It is a product from Red Hat, and we'll be working on that along with Kubernetes and OpenStack. So this is a 30 hours course, which would be covering from basic skills of shell scripting, cloud, two DevOps technologies which we would be reading, and this is the syllabus, which would include basic of DevOps, scripting fundamentals. This is version controlling through Git, which is a very basic version control tool and which is very famous in the job market today. Then we would be covering Jet and Jenkins integration. And finally, we'll go to continuous integration with Jenkins, how to deploy our code with Jenkins and how can we do the integration on a daily basis as soon as the code is committed to the master branch by the developer. Then we'll go to continuous testing. We'll be using some tools like JUnit, PHP Unit for that, and we'll be using Jenkins as well. After that, we'll go to continuous deployments. These deployments can be done through Jenkins or Kubernetes or Dockerization as well. Then we'll discuss about containerization with Docker, how to build containers, how to manage containers, how to do peering of containers, and the same thing with Kubernetes as well. Then we'll go to Puppet, which is a configuration management tool, and finally continuous monitoring. Here we'll be using the ELK stack, that is Elasticsearch, Logstash, and Kibana. All these three are integrated together and work together to show you the results in Kibana dashboard. So, is it clear? Any further questions? Can you hear me now, Prakash? Hello? Hello? Am I audible to you guys?
Hello, sir.
Hello.
Yes, please go ahead.
Okay. So, what is DevOps? This is a strategy which would be used by developers and testers and IT operations. Today, there's a huge gap between developers and testers and the IT operation part of the IT industry. So, what DevOps does is it is a strategy and it tries to bridge the gap between these three things: it- the development team, the testing team, and the operations team. So, as a DevOps engineer, you'll be working with all three teams. You have to be the developer, you have to be the tester, and you have to be a part of IT operations. Before DevOps team, the development and the operations team were totally isolated. Just imagine a case when a development started and it had been completed, and later the operations team had to do the release. But there was a issue during the release, and though both the teams were totally isolated. So what exactly happened? So the change ticket was created and it passed on to the development team, and the hotfix could have been a solution over here when the development and operations team were working together, but it didn't work because of the isolation of between the teams, and the process got delayed and eventually the product got failed. So this is what DevOps try to do. It tries to bridge the gap by doing the development, by doing the testing, by doing the deployments and the operations as well. So as a developer, as an operations team, what all skills you have, you'll be using it in your DevOps stage. So there's a large amount of time which goes off in testing and deployment and designing, which all would be done by a single person. There's no manual code deployment, which most of the time leads to errors. We'll be using automation and tools for this. And there's no sync within the teams. There was no sync within the teams, because of which we had some issues, many issues actually. And today we'll be bridging that as well with DevOps course. So How DevOps is different from traditional IT. I'll show you, I'll give you four scenarios today. The first scenario is uh, you'll be responsible for creating new servers today. So when you create new servers, the development team works on testing, the operation teams work on extensive paperwork of the servers. But as a DevOps professional, it will take you minutes just to provision and do all these things using AWS console or Microsoft Azure or VMware, which we'll be seeing in this course as well. It's just a matter of around 2 minutes just to provision one server or many at a time. So just imagine situation two, there was a project and there was a projection of failover for the application. The redundancy and data center locations and storage requirements were skewed as no inputs are available from developers. And tomorrow, being in the operation team, you'll be held responsible. So in that case also, the DevOps, which is a traditional strategy, it will help you work upon all these things with your experience on the domain. And let's imagine the situation three, in which operation teams has no clue about the progress of development team. They are responsible for doing the release today of the application, and they are still waiting for the build from the development team, and there's no response from them. So in that case, also you see how these two teams has been isolated, and DevOps is the strategy which will take care of both the things by a single person or by a single team who all are DevOps professionals. So there would be no gap over there. And finally, before going live, just imagine a situation when load testing crashes the application. What require what requires at this point is the load testing of the application. This is not done, it's all gone. So what would happen is, as a DevOps professional, you'll be taking care of the load testing so that and the hotfix as well, which needs to be deployed as soon as possible so that the application release can be performed successfully. So why DevOps is used? There are various reasons. The first is predictability. As a DevOps professional, you will be able to predict what your application can go through, and you will be taking care of all the bad scenarios which can come up into your mind. Then comes the reproducibility. There's a small application which is going on a large scale tomorrow. It is your job to make sure that you do the scaling of this application, and it makes sure that the CPU, that the memory is extensive enough so that everybody can understand it, how it is working, and the application can take the load. Then comes maintainability. You have raised the strength of the application server. You have taken care of all the metrics which could have been gone wrong. Everything is running fine, but you need to make sure that it goes on for a long basis. The server quality is good enough, the monitoring is good enough, all those things are taken care by DevOps. Finally, the time to market. Whenever you provision a server, configuration management has to be done, some softwares has to be installed. After that, the application has to be deployed, the coding happens. There are many stages of a software development life cycle. So what happens usually in a traditional IT world, all these subjects are distributed onto different teams and there's a handover between them. So from the basic step of creating a server until the deployment to production support, there are various stages and it takes a lot of time, and a lot of time is wasted during the handover. So with DevOps, when single person is taking care of all those stages, what happens actually is a lot of time is saved. This is why DevOps is used. A greater quality is achieved as well, and a reduced risk is there of failover. The systems which are built are very resilient. With resilient, I mean that there are very less chances of failure for these systems, and it is cost efficient as well. When a person is involved in provisioning a server and taking care of the cost, and later he's involved in the development as well, and he knows how much of the performance he's needing from the provisioning of servers, the cost is saved in that case. And so many teams, the work of so many teams is done by one person with all the skills under his belt. That is why DevOps is used, and it breaks larger code into smaller pieces, which would be worked upon you guys. This is the DevOps lifecycle where you'll be responsible for all these things, and this course will be covering all these topics as well, so that you can make sure that you are confident enough while working as a DevOps engineer. So the first stage is code f- uh, of an existing application. In case you are building a application from the scratch, the first stage would be build. Here you will be provisioning the servers. We'll be using AWS for provisioning the servers, provisioning the auto scaling, provisioning the load balancers. Then we'll be getting into the server, configuring it using configuration management tools like Puppet or Docker. Then we'll be coding the application. For coding, we'll have a basic shell scripting course as well over here so that you can understand the code and write your code as well. Then you have to plan how big is the application going to be, either for existing one or yours. And depending upon that, we'll be setting up the load balancers, we'll setting up the databases, we'll be setting up the auto scaling, we'll be setting up monitoring platforms after that, which would include CloudWatch and ELB as well. And we'll be using a ELK stack, which is Elasticsearch, Logstash, and Kibana. This monitoring stack is the most famous in the market, and this Kibana dashboard provided by the ELK stack gives you the insight into every stage from build, code, plan, and monitor. Then finally, we'll go to operate, where we'll be where I'll be sharing some insight about the management of IT support and tickets and the operation of your servers. Finally, we'll do the deployment. This would be done through can be done through various tools like Kubernetes or containerization, or we can use AWS as well. The most famous tool for deployment today is Jenkins. We can use that as well. And then the application would be released, and then the testing would be done through various tools. We'll be using many AWS tools in this course as well, and CloudWatch as well. So earlier we had a traditional methodology called Agile. So how DevOps is different from Agile? If you see the first row, the software requirement and the customer was in touch with the developer and the tester, but there was always a gap with operations and IT infrastructure. This gap was bridged by the DevOps strategy. But in Agile, if you see, there's always a gap between customer and software requirement, which is bridged by Agile. So what happens is with DevOps, we try to bridge the gap between customer, the developer, the tester, and the operations as well. This operations include IT infrastructure. Today, that is the reason we go with DevOps. So these are some principles which we need to keep in mind as we work as a DevOps engineer. This is always customer centric. We always try to see what the customer wants. We always try to see what are the exact requirements of the customer. Even in case when the customer is confused with his own requirements, we'll try to understand him and try to make him understand what is required by the application. As a DevOps professional, we'll be responsible for end-to-end deployments from starting of building a code or a server to the deployment of application. It's end-to-end responsibility of a single person. It's a huge responsibility taking care of millions of rupees since you'll be working as a DevOps professional with a IT firm. A continuous improvement is your principle, should be your principle, because when you're working, it's not just your job to code and deploy every day. You need to make sure that you are using the tools which are available in the market. You're growing along with the market trend so that you can improve the way you are working, the way the applications are working. You need to automate everything. And for that, we'll be learning many tools today. You need to work as a team so that You can work on provisioning, you can work on testing, you can work on operations, you can work on deployments, everything together. It is not a one man job. So you need to work as a team so that everybody is aware about everything is which is going on in the team. Finally, when the application is deployed, you need to make sure that the monitoring is going on and you are testing everything on a daily basis. Because if anything crashes, you need to be safe for a better tomorrow rather than being sorry. So today I'll be covering some Linux fundamentals, and these would be a part of a DevOps journey, and which is very important. As a demo course, as a demo today, I'll be sharing some insight into Linux fundamentals, and after that we'll go to the AWS dashboard and I'll show you some modules, how it works and where we are going through. So why shell scripting? As a DevOps engineer, I could have asked you to learn PHP, I could have asked you to learn Java or Angular or any other thing which can get you into coding. But why we go through Linux fundamentals? This is something which is integrated with every other language, every database. You can use shell scripting and make sure that your code is implemented with Java, your code is implemented with Angular, and you can use those codes in your shell scripts. This is the most extensive scripting language in the world now. It had been there since 1980s, and today also we need this, and it has a same future, same need for tomorrow as well. So I'll show you how to create a basic shell script, how to call a script, what is the shebang, what are the naming conventions, what are the variables, how to declare variables, how to debug a script. I'll show you all these things now. So I'll be sharing my terminal window, which would make it clear. So I hope you guys are able to see it. This is a shell scripting window. Here we'll be starting what is shell scripting. So if I tell you about shell scripts, it is a command line argument where you can ask the system to take care of things. I'm logged into a Unix system. You can do the same thing in Windows as well. There's no hard and fast rule. You need to use a Ubuntu or a Linux system or a Red Hat, anyone. You can use any operating system and you can work on shell scripting. Today I'm using Ubuntu. In my next session, I'll be using a Windows session to make it clear to you how to use it. So there are some basic commands. First, I'll tell you about wherever you are, you can see your path. So this is my home directory, which is /home/prince. We can see it using the command pwd, present working directory. Then we can list the files over here as well. And before that, I'll show you how to create a directory. This is mkdir. This is for making a directory. So mkdir space the name of directory. How to change the directory. These are some basic commands which we would need in shell scripting and even later as well. So cd space the directory name, enter. So if we click on pwd again, it shows the present working directory is home/prince/training. Okay. And after that, we'll try to see what are the contents of this file. So this is for ls. Ls is an acronym for listing. When we click on listing, it shows nothing over here because I just created this new directory and there was no contents inside this. So let me create some files. Now I'll do ls. You can see there are three files, and if I do ls-l, it would give me a long listing. There are various columns in this. The first column is for permissions. The second, we can ignore this. When we go deeper in the course, I'll explain you that. The third is the user, who's the responsible person for this file. The fourth is the owner of this file. Then then comes the date at which, and we'll skip this field, this column, and then it shows the date when it was created. We can even modify it and ask for the timestamp as well, which would show until milliseconds at what time it was created. But we'll go into that later. And finally, we have the file name. So sometimes what happens is there are hidden files as well. How to look into that? First, I'll create a hidden file. So if you see, I created one hidden file. This was a file name, but this file is not responsible. This command is not responsible, and the file is not shown over here. We still have those three files itself, A, B, and C. How to see that? When we press the command ls-la, it is responsible for showing all the hidden files. So now we have this dot hidden file, but you see that there are two more things over here, and it shows something different over here as well. What is it actually? The first letter of this part of column is D. D refers to a directory. The double dot is referring to the previous directory, and single dot is referring to a root directory. Whenever you do ls-la, it shows the first line as total number of files. Then it shows all the file names which are present. Along with that, it shows the hidden file over there. And finally, it shows the current directory and the parent directory or the root directory as well. So these are some things which everyone should know. So how do we create a shell script? So what we'll do, we'll try to open how to open a file first of all. So we have various editors, like we have Notepad in Windows. We call it Vim editor. So there is a file which we already created, which was called A. When I entered into A, you can see it's blank. The command which I used is vim for the opening the editor, and then the file name. This is Vim editor. We can use vi editor as well. Okay. And there are basic commands inside the editor as well. So once I do vim, I get in. There are some commands which we can use over here, like to save and exit. After I make some changes, I entered this. I need to save and exit. I'll press escape, then the colon, and press WQ. WQ is the symbol for saving and exit. And if I want to make some changes, then I realize that this is not required. And I want the file as it is, and I don't want to save but just exit the file. This happens a lot when we are trying to debug a file and by mistake we press enter or anything and we change something in the log file or in the main script. In that case, what you would do is press colon, Q, and exclamation mark. Exclamation mark refers to a force exit. Okay, so we'll just press this and you can see nothing happened over here. So when we see VIA again, there would be nothing inside because we forced exit without saving. So there would be cases where you don't want to get into a file because you want to make sure that there are no changes from your end from anybody's end. So you'll use cat command over there. Cat command, what it would do is it would make sure that the contents of file are shown, but you don't make any changes to it. So you don't get into it. It comes out and shows you the content of the file. So over here, it didn't show anything because the file was empty. If we do cat b, so this was the only line which was there. If there are 1000 lines, it would show those. Okay. So there are many other commands as well, like tail and others as well. Tail and head, we'll get into that when we go deeper into Linux shell scripting. So how do we create a script and call a script? Whenever we create a script, we need to make sure the extension of the file ends with .sh. So the first script which we'll create is vim first .sh. This is .sh is something which we need to append at the end of every script to make sure that the system understands it's a shell script. So when we do that, inside shell scripts, we write the shell commands like the basic commands which I just showed you. We can write we can write pwd. Sorry. So we can write pwd over here. We can write ls-la. But make sure before all this, all what you write, you use the shebang over here. What is shebang? We write it using /bin /bash and starting with the hash and the exclamation mark. I'll explain you what exactly it does. When anything starts with a hash over here, everything is commented, which is being followed. So why the whole thing? This is the reason whenever we are talking about shell, there are many shell scripting. There are many basic shells inside this, like the cron shell, like the bash shell, like the Bourne shell, Bourne, Bourne shell. You can Google all these things. So all these shells are responsible for some fork jobs, some small part of jobs which are being executed by the shell itself, the whole big shell itself. So instead of these, instead of these doing their own jobs, what this command specifies is that the bash shell would be responsible for taking care of the execution. So finally, what it does is you can see the script has pwd, ls-la, and many other things. But what we would do, we would try to execute a shell script with bash, and I'll show you how. So first, we need to save and exit the file, which has two basic commands, pwd and ls-la. So when I do save and exit, and I do ls-la over here, you can see the file is created, first.sh. And you can see these are the permissions over here. These are the permissions: read write, and read only. So what would happen when we try to execute? The command we execute is /first.sh. What happened over here? It showed permission denied. This is a issue because of permissions. And before executing any shell file, we need to give it permissions to be executed. You can see over here there is RW, but there was no X over here. There was no X over here, and there was no X over here. So we are not allowed to do that. So we'll use the command chmod. Chmod is for changing the permissions. These permissions would be, I'll be explaining you later. As a part of this demo, I'll just make it fully permissible to be modified to be executed. And then I'll put the file name chmod 777 and then the file name, that is first.sh. And then we'll run the same command /first.sh for executing. So what happened over here? The first command was executed, home prints /training. Okay. That was the pwd command, and then this command was executed, ls-la. Okay, then when an ls-la was executed, all these things came up, whatever we saw earlier after executing ls-la. Okay, so this is how we execute a shell script. I'll tell you a little about variables today as well. How do we declare a variable? So I'll just put x equal to 2. When we do a echo $x, so what would happen? Did you understand what happened over here? So x is a variable and a value 2 is assigned to the variable x. And when we do a echo, it is responsible for telling you what actually is the value of x. So right now, if I do echo $y, there was no variable, there was no value which was just assigned to y until now. But now we'll be assigning something to y equal to 5. And when we do echo 5 now, echo $y now, we can see the value has been assigned to y. So this is variable assigning. And I'll show you debugging, how to debug a shell script. So until now we used // to run the shell script, right? And it gives us this output. For debugging, we use another command which is known as bash-x. Bash-x, then the file name. What happened over here is it showed plus pwd. It meant this is the first command it came across while executing the script. As soon as it saw plus pwd over there, it executed this, and then another command came across the bash x, that was ls-la, and it was executed. This is a very helpful feature when you execute some long scripts and you are not able to see where the error is coming across, and where you want to see what is the procedure for loops, for if-else statements and other variables and the classes when it's being called. Then I'll show a little hands-on on AWS dashboard as well today, which would be the last part of the demo. So I'm on the AWS dashboard right now. To get here, you need to create an account. For this, you need to give your credit card or debit card details. After reaching over here, you can see management console. There are a lot of things over here. We'll be covering almost everything over here as a part of this course. The first thing I want to show you is EC2. EC2 is nothing but Elastic Compute Cloud. It is a very nice name and a nice naming thing given by AWS, which is nothing but actually just for creation, provisioning, termination, deletion of your EC2 servers or your instances. These instances could be database or Linux or Windows or any other thing. So I'll show you today to create one instance. Usually just imagine you are working in an IT company and the requirement comes up, you need to set up a new application. For that, you need to create some new servers. So what happens? You first go to the purchasing team. They're responsible for creating the bills. Then you go to the data center provider, the server provider, which could be anything like IBM or anyone. Then you go to them, pay for the server, and you request them for a server. Then they provision you a server. Then after that, you need to check for the security so that nobody else from the public domain is able to access your server, your things. So then after that, you get into the server, you check your connections. After that, you test everything. And all this procedure takes at least a month or two. But with AWS, what we'll be doing is we'll be creating a server within a minute. So after services, the first thing we go to is compute. Under compute, we have EC2, that is Elastic Compute Cloud. and I'll be clicking on the button of launch instance. There are many things shown on this page right now. We'll get into it when we go detailed into the course. So we'll click on the first one, which is a Amazon Linux AMI. If you see the list below, there are a lot of various options: SUAC Linux, Red Hat, Ubuntu, and Windows as well. So what we'll do, the first thing we need to select is the type of system you want. We'll go with Amazon Linux for demo purposes. Then you select what is the family, what is the type, how many CPU cores you want, what is the memory, what is the instance storage types. This is elastic block storage. We'll be discussing that as well in the course when we go deep. Then the network performance, then the IPv6 v6 support. So I'll just click on general purpose just to show you how fast it is when you know everything what you are doing. So we click on network. These are some basic networks, default ones which are already created. I'll click on add storage. This is the amount of storage you can add. Just for testing purposes, we'll be leaving into the default values. You can see volume types are three. This is general purpose SSD. This is provision IOPS and magnetic. You must remember magnetic from our old days, right? We had magnetic storage in our hard drives and everywhere earlier. But these days it's used for old data only. Then we'll be using tags. It is not mandatory to add tags. These are used for shell scripts and scripts for CLI, the command line arguments of AWS. Even if we don't add anything over here, we can leave it as it is. We can click on next, configure security groups. Here we'll be leaving it to default. Okay, and we'll just review and launch. So this is the final details of our storage. You can see everything which is going on over here. We'll get into billing as well a little. So this is the final step where we need to create a key pair to connect to it, or we can use the existing pair and create any key pair which is name test. Then we have to download the key file. Okay, for demo purposes, I already created test, so it wasn't being downloaded. Now it's downloaded. I'll save the file and I'll launch the instance. So if we go to the EC2 dashboard again, view instances at the bottom of the page, it will show that the instance state is pending and it won't take more than a minute to be created. So that's all. You have already created a server. You are having a Red Hat machine now. You could have done for Windows as well. Just imagine how quick and how easy it is to do that. So we'll check on Elastic Load Balancer as well. I'll show you what it is actually. Elastic Load Balancer, just imagine a situation when there is an application, a web application, just like Google or anything like we use a Yahoo Mail. There were 50 users who were using Yahoo Mail in the morning. And by the end of the day, it had been Microsoft or some other organization such as Apple said, we'll be using Yahoo Mail as well for some public access to our mails because we don't want to use our private mails, which is Apple Mail. So what we'll do over here is when they migrated to Yahoo Mail, from 50 users, it became 500 and then 5,000. But the servers for Yahoo Mail, which were allocated, crashed. In that case, what would happen is Elastic Load Balancer would come into play where another set of servers would be hosted in another availability zone or another area. So what would happen is the first zone, when it went down, when it crashed, Elastic Load Balancer would be taking care of just switching the zone and making sure that everything is up and running. So load balancers are in the same section as EC2. When we go to the EC2 dashboard, over here we have create load balancer. Over here, we have three type of load balancers. Actually, it is two only. The first and the second are the same thing. It is a part of application load balancer, and the third is classic load balancer, also known as the elastic load balancer. So I'll show you the older one today. So it asks the load balancer name. You can give any load balancer name. Then it asks for the protocol which it is using. Is it HTTP or HTTPS or TCP or SSL? So we leave everything at defaults just for demo purposes. Then we'll assign the security groups. So we need to create the subnet as well for load balancers. Otherwise, it won't uh, allow us to proceed with that. Then we need to create security groups, then configure security groups. And finally, we need to add the instances from the two zones. Okay. And review and launch at the last stage. That easy. We'll go. I look forward to going into it with you guys in the next part of the course. So then comes RDS. So what we did was until now we just provisioned some servers which were having Windows, or we could have used Ubuntu as well. So if we talk about databases, what would happen? We'll show that in this part of the service as well in RDS. RDS is nothing but relational database services. We'll try to create a database now to show how easy and quick it is. So we'll just click on create database, and it would give us whole lot of options over here. What engine can we use? It supports Oracle, MS SQL, PostgreSQL. These are MariaDB, MySQL, and Amazon Aurora. Amazon Aurora is one of the fastest engines provided by Amazon itself. We can select license, we can bring our own license, and or we can use Amazon's AWS license and choose editions which are available in the market as well. If we click on next, I won't be provisioning it for the moment because of billing purposes and for demo purposes. And then it comes for use case. There's always a difference between test and production, whatever you're deploying in AWS. Why? Because dev and test are supposed to be for personal usage, for individual developers usage, and production is supposed to be for the end users usage, which is never supposed to go down. So in case of production, what happens is there's always a multi AZ deployment or availability zone deployment. What I mean by this is if I click on this arrow drop down list on the top of my page, it shows Mumbai right now. I can choose any of these places. It is not just a part of the map, it is where the data center of AWS is hosted. So the best practices says that whenever try to deploy a production server, I make sure that I have a replica of it ready in another zone as well. In case a zone goes down, because it could be because of anything. These are all machines. Even if they say that there is a 99.99% chance that it would be up and running all the time, there is still a very minute chance of its failover. Or there could be natural disaster. Just imagine in Singapore there was an earthquake or anything and the data center got lost. In that case, we won't be able to blame AWS because it's something which can happen anywhere around the world. So in that case, we need to make sure that our production servers are also there in Seoul or Sydney or Tokyo so that the deployment happens in a replica basis and nothing goes down in case of any emergency. So we'll use dev or test now. When we click on next, we need to specify the DB details. For Oracle, we need to always choose the license since it is not a open source tool. So either we can bring our own license. It's depending upon the edition we chose. It doesn't give us an option to take a license from them. So we'll choose bring our own license. Over here, we'll use the version. You can see there's a whole list of version which is given over here. Then we can choose the class, how many cores of CPU and how much of the RAM we need. This would be part of the architecture of the application. Then we'll use the storage type, which is SSD or provisioned IOPS. We'll get into that later. So how much storage we need for this Oracle database, and this is the total price. So we are on the final page. We just need to set up some VPC after this, which would be part of this course as well. And this is the bill, which would be created by the DB instance. So these are some settings, which are some mandatory fields. What is the DB instance modifier or the identifier, which would be used for connection? Then comes the username and password. Since these are some advanced and mandatory fields, we need to enter that before proceeding. Until that, we can't do that. So we'll be getting into that as a part of this course as well. Then comes CloudWatch, which is used for monitoring, and IAM is for user management. Then comes Route 53 and EFS, which we would be covering as a part of this course as well. Thank you everyone for being a part of this course. We look forward to seeing you soon. And let me know in case you have any questions at the end of this course. Yes, Prakash. So we will be using AWS. As a part of this DevOps training, we need some platform to show you what CloudWatch is, what all monitoring tools are there in in the market, open source tools like Jenkins. But we need a platform to deploy these tools on. I can do that on my local system, but it wouldn't give you the experience on how to work on that in a daily basis on in the market. So I'll be using AWS as a platform. If your preferences as a student are Microsoft Azure, we can go with that as well, or any other platform which is available, like VMware. We have basic extensive experience on any of those. Any other question? Okay, we have another student. So, okay, good question. So, as a part of the DevOps course, we'll be making sure that you have an experience on continuous integration, continuous deployments, and monitoring. Those are the three main pillars of DevOps course. So in that, we have many tools which you need to learn as a part of this course. So we'll be learning versioning control using Git, Jenkins. Then we'll be moving on to continuous deployments using Jenkins. Then after this is done, we'll be doing a testing, which can be done through Jenkins itself, but we'll be using many other tools like PHP unit, JUnit, depending upon the type of application. And then we'll be using a Nexus. Nexus is a repository, a source code repository, which is used for versioning control, which is used for continuous deployments. After that, we'll be working with SonarQube as well. This is a code quality tool. In SonarCube, the code quality tool, it checks how good is the code written, how efficient is the code written, which can't be done manually. It is just one tool which is very efficient and tells in numbers, in exact numbers, how good is the code. After that, we'll be going to ELK, that is the monitoring of, and along with that, we'll go into basics of cloud dockerization as well. That's all that would be covered. I didn't get you, Prakash. In order to practice what? In order to practice, it is not whatever I thought. It is whatever we are going to practice on AWS platform. We'll be setting up these tools. I'll show you how the basic tools works and how you can use it for your code, how you can use it on a daily basis. So we'll be working a little into every tool. We'll give you an insight on every tool, and we'll teach you as well how to deploy your own code, how to deploy your own tool. Whenever we start with any tool, I'll tell you how to deploy it on your own system, and that would be very much recommended so that you can take away the learning of this course along with you to the future. Because without practice, you won't be able to work on it. You need to deploy, you need to see the deployment process over here, and you can take those deployment to your system and you need to deploy there. I hope everything is clear now.
Hi. No, I what I'm asking is whatever you teach, right? I need to practice those end of the day. So how do I do that? Oh,
So Prakash,
so
what is you have a system with you, right?
no, I know AWS, so I have an account. I can create a sequence
Okay,
and all those
that's
things.
good. AWS is just for basics
Right.
of creating instance and all. When I talk about any of the tools like Git, Jenkins, when we
Mhm.
go deep dive into those tools, we need to make sure, I will make sure that I show you how to deploy the application. Okay,
Okay.
so you need
No,
to do the
I know
same thing
you.
on your system.
Yeah,
Yeah,
I want to do same thing on my system. So that's what I. So those some of the tools are like it's a free tool, right? We
yeah,
download the version of those.
yeah, this is an open source tool. Yeah,
Yeah, open source tools. Yes.
so along with free tools, mostly what happens is I am part of three MNCs right now. What happens over here is in all the three MNCs, the strategy today is same. They all are moving to open source. Today, Oracle is there. They are big market players, but everybody is focusing still on open source. So what our course would be doing is we'll be focusing on open source tools as well, which are the most in demand in the market today. So I'll show you how to deploy those, how to use those, and how to integrate those with each other. That would be a part of this course. Okay, and
Okay.
it's your
Yeah.
job to deploy the same thing on your system to have a hands-on.
Okay. Okay.
Okay. um I
Which where
think
do you work?
that is actually confidential. As a
Oh,
part of this training, I won't be
okay.
able to share that with you.
Okay. No, no problem. I'm just
Okay.
out of
Okay.
curiosity. That's
Okay, thanks Prakash. Okay, so we'll be ending the demo session today. I hope to look forward to you guys
all.
in
Okay.
the next session. See you. Bye bye.